Well guys, here we are again in another one of my episodes on how to learn software development. It would be easier, of course, if you did watch the previous installment of this series as well, so you know easier what I'm talking about in these upcoming videos. Okay, so what we discussed last time was basically what is a simple software program, and how does binary work, the basis of all communication and data storage and instruction execution, etc., of programs and so forth on computers. Today we're going to look a little bit at what exactly is data, what defines data, and how we can use it and manipulate it in a program to our desire to get the results we want. Okay, so we basically start with a simple point that actually everything is data. It's not a software program or data. A software program itself is data. I mean, you might want to save a software program into a text file. Well, that makes that software program data stored in a text file. That data might mean something when you read it and look at it. It possesses some characteristic which is more abstract than the actual characters saved in the file, but ultimately to keep that data in a computer for execution or for later recall, for later usage, it's basically just to be considered data. But for our purposes, we're going to try and draw a distinction between data, which is used by a computer program, and then a computer program itself, which we are not going to refer to as data anymore, although ultimately it is also just data. Anything that's an input to something else or an output from something else is considered data, but we're going to stick to the basics. So the first thing is data itself. You get different kinds of data. Well, I shouldn't say different kinds. All data is basically bits and bytes, like covered in the previous video with describing binary. But those bits and bytes all have a context. So let's say, for instance, you want to save a ASCII character, with a string, okay, of characters. Like cows will never jump over the moon. You want to save that into a text file, for instance. Each one of those characters is actually an 8-bit byte. So let's say the word cow, C-O-W. The C is an 8-bit byte that's got a certain number embedded in it. And the O has got a different number, and the W has got a different number. So every one of the ASCII characters has got a different number to differentiate it from all the others. And this is a standard. ASCII meaning the American Standard Code for Information Interchange. It's been decided many years ago that number 96 or 7 will be an A, etc. And like 32 is a space. If you press the space bar. If I remember correctly, 13 is if you press the enter. But then you got all the special characters, the numbers, and all those things. But don't get confused with number as a character and number as data. Okay, stored in a byte as that number. So what I'm saying is, even though in a byte you can store up to, let's say, a maximum number of 255, and you want to store, let's say, for instance, a number 97 in it. All right, you store the number 97, but the program that's going to use that byte that you just stored 97 into, it's got to know, are you referring to the actual numerical number 97, or is that actually just a number which is a code in a lookup table which should return, for instance, the character A or B or C or whatever. So even though the data, the byte, looks the exact same in both cases for a number and for a character, it's the context in which it is used. The computer must know that you're referring to this number as a number, as 96 or 97 or 98, or use this number, let's say 96, and look up in the ASCII table what is the equivalent alphanumeric character or ASCII character, and then use that rather. So instead of, like, if I press on my keyboard an A, it doesn't write to the screen number 96 or 97 or 98. It doesn't write a number. It actually writes that number, where after it's done a lookup call to the ASCII table, and then it writes out the letter A. So in other words, 96 or 97 relates to the letter A, all right, in a certain context. And the computer's got to be aware of the context that you're working in. And in other cases, that 97 is literally just a number. You might want to add 97 and 12. You can't like add alphabetic characters together. You know, a plus a B is not a C. You know, it's okay. Sure, you can say in algebraic maths it does, but we're talking straight characters here now. You can't take two characters and add them. That maths doesn't exist. Maths exists on numbers. All right, so the computer's got to be aware. Are you talking about characters or are you talking about numbers? Okay, so let's jump into primitive data types. There are many different types of data that you can store on a computer. Like I say, you can store a string, you know, hello, my name is Fred, etc., a whole string of characters. But typically the computer actually only works in numbers, like just said. And the numbers are used to represent certain things that we can use. So in other words, different, like let's say for instance you have a byte which consists of 8 bits. That can be used as a boolean, for instance. It's a data type called a boolean, which is either true or false. And booleans are very important because they get used in what we'll discuss later, conditional statements and etc. And to see if something is true or false, basically. Another set of primitive data types are, of course, the maximum numbers you can have for the bits and the bytes that you're dealing with. So if you're dealing with a byte itself, which can have up to a maximum of 256 combinations, or a biggest number of 255, okay, that is a data type which is typically referred to as a byte. All right, it's an easy one to remember. A byte data type refers to a byte as in a byte in the computer. Then sometimes you want to store a bigger number, and the computer only doesn't work in half bytes. Okay, it uses entire bytes. So if you want to go bigger than 255, let's say you want 300, you can't just add an extra bit and make it a 9-bit byte. You have to use a complete new byte. Okay, so you're now using 2 bytes. So initially the maximum number you could have had was 255. Now you've got another 8 bits that you can use from a new byte, but it doesn't start again at 2 to the 0. It continues from where the last one ended off at 2 to the 7. It now becomes 2 to the 8, 2 to the 9, and so it goes up to 2 to the 15. And it allows you to have a much bigger number than 255. It's, well, 2 to the power 16, and that'll give you 60, I can't remember, 65,000 something, as a maximum number. Okay, so this brings us nicely to our next point, which is data storage and how to access them from your programming language. So we're moving away now from actual hardware, how the hardware works, and actually more into the programming language itself. Now, all programming languages basically have, well, not all, but probably 99% of them, have this construct or this concept called a variable. A variable is basically just a pointer that is used to point to a piece of RAM in which some bytes have been stored. Like we were talking about, you know, you can manipulate bytes, you can put numbers in them and so forth, but you need to sometimes store these things somewhere while you're working with them, and you stick them into memory, and that is called a variable. There are some things, such as, for instance, constants. They are ultimately still, you can consider them as variables, but they are unchangeable variables. So variables, as the word would suggest to you, is you can change the data inside it. There are some catches to that, like when you're dealing with mutability and so forth. But you can go read up on what mutability is, mutable and immutable variables. So as I say, so every little piece of memory you want to use and save something into, you call a variable. So that's the basic idea of variables. Variables can be of many data types. There are what they call the primitive data types, and these are ones that I've already covered. That is, for instance, your 16-bit numbers, 64-bit numbers. Ultimately, remember, everything is a number. It's just, let's say in the case of a character, a byte is also just a number. Let's say 96 is the number, or 97, I always forget. But you're telling the computer in your program that don't use that as a number, but rather do a lookup to the ASCII table and return to me the value of A. In other words, whatever 97 maps to in the ASCII table. There are other tables as well, with different characters, bigger characters, etc., more characters and so forth. But we're all basically using, for day-to-day work, we're using ASCII. Then that's another important thing when I say for day-to-day work. A lot of programming languages, when they refer to strings, they are not necessarily referring to ASCII characters, but rather to UTF-8 or UTF-16. As far as I know, UTF-8 is the most popular. We're used to dealing with ASCII, A, B, C, D, E, but there is UTF-8 and 16 for international characters as well. All right, then that brings us to our next step. So you've got just a variable, all right, and you say it's a surname, and you give it a data type of type string. Okay, the computer knows, the compiler knows how to convert that string, those numbers, those characters which exist together to make up a string. It knows how to do that conversion for you. So when it saves away, like for instance, number 97, number 99, number 103, and it saves all these numbers away. And one day when you execute your program and you want to read that back again, it does the inverse of it, because it knows you're referring to a string, and therefore it mustn't be 96, but it must be A. With numbers itself, it doesn't have to do that. It just retrieves the numbers as are. Then another construct when it comes to variables is the idea of an array. An array is basically in one go declaring many variables, all right, to hold data. So in other words, let's say for instance you know that you've got 100 friends, and you would like to put all of them into your program for whatever reason may be. You can you can capture them one at a time, or read out of a text file, or read Twitter and pull them all out, and somehow you get a list of 100 names of your friends. Now you don't want to create a variable for each friend, so then you got to tell the computer, okay, retrieve these 100 names, or retrieve them one at a time, and for each one of them create a variable called my friend 1, then my friend 2, my friend 3 for 100. Now you've got these 100 variables. It's unwieldy and it's just impractical. You've got something that can help you there, which is called an array. Now an array is something that you give a boundary to. It's a variable to which you say, okay, I'm going to be storing a bunch of strings in it, all right, because it's your friends' names, which are strings, and the name is my friends' names, all right, and you tell it asks you, so what size must it be in the programming language? You tell them, well, I want to have 100 let's call them variables inside the array, but it's normally referred to as indexes. And you say you've got one variable, and you can put all 100 of your friends inside that one variable. If you need to refer to a specific friend, you use that array name, and you do what we call, you do an index on it. So let's say you want to retrieve your third friend, for instance, all right, then you would think, okay, so you can say my friends array, and then the index you normally put in square brackets right after the variable name, and then you put in 3, and it'll return to you your friend's name that's in the third position. There's one little caveat to it. When you're dealing with many things in programming languages, such as arrays as well, counting does not start at 1. Counting starts at 0. All right. So if you want to access your third friend, you don't retrieve the index 3, you retrieve the index 2, because your first friend is at index 0, your second friend is at 1, and your third friend is at 2. Alright, so you don't call index 3 because that's going to retrieve actually the fourth one. You want the third one. Alright. Now ultimately the basic concept of an array is you can store anything inside that array, but a lot of languages limit you to a particular data type which you declare when you create the array. So when you say, for instance, create an array for all my friends' names, you've got to tell them that it's an array of type string. But in some cases you can have arrays that's got thousands or millions of elements in it. And arrays really are your friends. So instead of creating a million variables, you create one array but with a million indexable cells within it, which contains the data that you want to store in the individual variable. Now the really great thing about arrays is that what I described to you now is referred to as a one-dimensional array. So in other words, it's just basically if you think of each index point, each one of them is an array, a variable. So if your array is a million indexes or cells long, you've got a million variables. But the nice thing about arrays is you can have two-dimensional arrays. And 3, 4, 5, 6-dimensional arrays, which make them extremely powerful. But we'll cover this a little bit later when we get more into the programming side of stuff. Alright, so that's basically covering the idea behind a variable that is accessible by name, which you choose the name. You can't make it any name because some names are obviously reserved to the programming language you're working in. So if there's a certain command in the programming language, let's say for instance print, okay, you can't call your variable print because the language itself already uses the word print, so you've got to call it something else. Another thing about variables is how you name them. It's good practice to name them as descriptive as possible. There are rules amongst different programming languages of how you name your variables. They typically use a scheme where they do something like what they call snake case, which for instance has an underline between each word in your variable. So let's say it's my friends, so it'll be lower score my, then underscore friends, everything lower score. You've got camel case, you've got Pascal case, etc. C# for instance has different casing for depending on what exactly you're referring to. If you're referring to a variable, then you start with a lowercase and the second word will be the first uppercase. But when you, for instance, naming your functions, which we'll get to later, you know, that starts with a capital again. But there's these rules amongst different languages of how you exactly, you know, for instance, name your variables, name your methods, and so forth. So I think this brings us now to the end of this video. We basically had a quick look at how to store data in computer's memory using some of the primitive data types. There are other data types that are built on these primitives, but data types themselves being the primitive ones we looked at. And then we also looked at arrays, which are absolutely amazing. You will love them one day. Very powerful stuff to use. Yes, I think that's it. And next time we will be working on getting into pseudocode. So yes, enjoy it, guys. I'll catch you next time. See you. Bye.